Hello, welcome folks. We're just going to give it a few more seconds to let the waiting room clear. I can see there's still some folks coming in from the waiting room, so we will start in just about 30 seconds or so. For those who just joined, we're just giving it a few seconds for the waiting room to clear, and we'll get kicked off. All right, I think we're pretty much clear at this point, so we're going to go ahead and get started. I'd like to welcome everyone to this LF Energy webinar on guided substation engineering with CoMPAS, simplifying IEC 61850. We are lucky to have with us today two great experts on this topic, Christian Ropp of Transnet BW and Stefan Baumgartner of Bearing Point. I will note that if you have any questions that arise at any time during the webinar, please click the Q&A button in the Zoom interface and submit those questions in writing. When we get to the end of the presentation, we will go through all of those questions in the order that they were received. With that, we will pass things over to get started to Stefan.
All right, thank you very much, Dan, and thank you very much for the organization and moderation. Just shortly to us, we are Christian and Stefan, and we're dealing since more than 5 years with IEC 61850 in the TSO environment, and we want to show you our newest solution within the CoMPAS ecosystem, and want to go directly into the details. Here we have our agenda. We have in 8 points the top-down engineering process itself, an example bay. We will talk about the wizarding and the plugins, how we do in best practice the functional engineering, how we will do the communication engineering, and in the end we will go a little bit more into the details of the data export and what we are already able to do with CoMPAS. After this presentation, we will have a live demo, so you can see we are not only showing you nice slides, but also have a real working solution there. And in the end, we will go into the conclusion. So then I would hand over to you, Christian.
Yeah, also from my side, welcome everyone. As many of you know, CoMPAS have a lot of awesome plugins, but only a very limited circle of people know in which sequence they should use the plugins to engineer Substation. So that's where the guided engineering comes into place, to guide the user through all these plugins to get a streamlined top-down workflow. Weiter?
No, sorry.
Okay. Top-down engineering. What we mean with top-down engineering. Here's a summarized overview how the process should look. In step 0, we plan the primary equipment of the substation. Basically, all the electrical, physical stuff that should be there. So no functional engineering in this step. All this electrical planning with the primary equipment gets compressed into one SSD file, which then gets imported into our CoMPAS environment and then gets enriched with another SSD file, which contains our types from our database that we have already created and defined. So data models, functions, and so on. Everything that I did previously, I also can import again and use again, or create newly in the CoMPAS environment if I don't have anything in the database already. So in CoMPAS, I do the whole functional engineering of the substation. So every function, every bit, every data flow, everything that goes on in the substation gets then defined there. Everything in CoMPAS. And then I will get a complete SCD file, which contains everything that describes the substation. So this SCD then gets exported from CoMPAS, then imported to our ICT tool, more on that later. And I also can import this SCD back into my electrical planning tool to may or may not enrich the electrical planning further based on the functional design that I made in CoMPAS, if this is necessary for our or your process. Yeah. Slides take a moment. Yeah. From the electrical planning tool, we can import also IEDs, number of IEDs, the names of them, what the hardware these IEDs contain, number of IOs, analog, digital, whatever. This all can or cannot be imported from your planning tool. This depends on what you want, import and which step, what your planning tool is capable of, and how you want to do things, basically. So all of this can be imported, but it's not necessarily to do import all of this. For our webinar, we do one example bay with a shunt reactor. So only this one bay. As you can see on the right side is the SLD from the planning tool and the TSLD view that can be recreated in CoMPAS based on the SCD right now. And we have the zero line diagram on the left, where it only shows which equipment is in the SCD present, but not how they connected. Yeah. Next slide.
All right, then I would a little bit go into the detail of creating your own tailored engineering process. We already mentioned that we now tell you a little bit more about the engineering wizard, which is a new plugin for CoMPAS. So this is a solution where you can create your own engineering process by drag and drop. So there is on the right-hand side the possibility to see all plugins, and you can drag and drop them into groups. So you can edit groups and add groups. And there you can also remove them and change the order. So why do we do that? So we have seen in the past, because we are a little bit more than 5 years into that topic, that it's always hard to know, okay, which plugin do I have to use when, and where do I need more data before I can use the next plugin. So now we have here a clear process and order, and this one is very user-centric and consistent. So it's tailored for your needs actually. And the best thing of this standard process, I would say, or your process, is that you have a standardized way you can reuse, and it's completely transparent, not only for you as the super expert user, but also for other users who want to get in touch with the IEC 6150 world, or want to learn how they can engineer IEC 6150 substations. In the end, it also reduces errors, because if you do not have the right order of plugins, then you will have some issues, and in the end, you won't be able to have a clear clue where the error happened or where did you miss to put in the right data. So this is the basic new idea of the engineering wizard. What's also very important that, as already mentioned, you can import SSD files from the planning tool to make the completely work easier, but it's not required or mandatory, let's say it like this. If we go here into our best practice order, Christian and I have somehow arranged. First of all, we have at step 0 the engineering wizard as a plugin. So it's not in the order of the engineering wizard itself, because it's the plugin which will be used for that. This one is made for the definition of the engineering process. After that, we have the template generator. This plugin is made for the creation of logical node types, the data object types, the data attribute types, and the enum types. After you have created all your, let's say, data model or all your types in the data model, then you can use those types and define your functions, equipment functions, and base. So you have more or less a stencil, or I think stencil is a good word, in the type designer. After the type designer, it's necessary to map the types you before have created with the real world, so with the electrical world, and this will happen in the type distributor. Currently, this type distributor is not available. It's in development, but there is a, let's say, workaround for that. After we have then the combination of the, let's say, template world and the physical real world, then we can go to the communication plugin where we can set up our networks and IEDs. And after that, we can create our communication, talking about the publishers. We can define our data sets, the reports like, buffered, unbuffered reports, the GOOSEs, and the sampled values. After that, it's possible then to somehow subscribe or define the client for the reports. And after that, actually, it's more or less finished from our side, and we can document the details in the Autodoc plugin, where we can create a documentation based on templates completely automatically. We will go into that topic a little bit later. With the history viewer, it's possible then to store those files in a database, version it, and export also the SCD and CID files. To have a little bit more structure in the whole SCL file chaos, it's also possible then to assign those SCL files to the location manager and the location viewer. So you have, for example, a substation 1 in, let's say, Berlin, and you want to put all the important data to the site, then you can do that in the location manager. And for the last part, we have the Archive Explorer, which is optional, but you can then archive data if it's not needed anymore, for example. All right, then we would like to go more into the details of the functional engineering. We have a completely new template generator. There has been one before, but now we had the idea or the need to somehow use the old template generator idea and the, let's say, very old template editor. They were two plugins, and we somehow tried to combine them too. So now we can create, edit the logical nodes. We can export and import the data and the types from the database. And now we have some kind of, the 6150 standard within the plugin with more mechanisms and automatics than before. So we have, for example, the default mechanism to speed up the standardization. It's only one click, and then you can say, okay, this is now the type you want to use. So there is no need anymore to look into the standard at all, which is sometimes a kind of a mess. All right, here, this is the default types, just in short. We will show it to you later. Keep in mind, currently we have developed it like that each logical node class has only one type as default. But yeah, we are in discussions for that and would be happy to get maybe some feedback from you as a community, how we can model it or develop it further. All right, then that's it from my side. I will hand over to the type designer, Christian.
Yep. So after we created our logical nodes, DO and DA types, in the template generator, we can then create our functions, equipment, and bay types in the type designer. So on the right side, you see that all ln types we have created are present. Then I can add the function types. So add basically a function and then drag the ln types into the function to fill it with functionality, basically. Then we can create equipment types, so general or conductive equipment. So a circuit breaker, disconnector, earth switch, transformers, lines, and everything the standard defines. We create these equipment types and then drag functions into these equipment types to create equipment functions, which add functionality to the equipment. And then in the last step, we drag equipment and function types into our bay type to create the functionality of our whole bay. That's the whole idea. And in the next slide, you can see how these references look like. So you have your bay type, which contains now, in this example, circuit breaker, 2 disconnectors, 3 earth switches, and so on and so forth. And then you can read the whole type designer from left to right. So you see the circuit breaker has a reference to the equipment type. The circuit breaker has then an equipment function, which is referenced to a function. And the function contains L nodes, which are referenced to the ln types. So you work from right to left by drag and drop and can read it from left to right. So it's straightforward and very easy to use. So then in the next step, after the type designer, comes the type distributor, which is currently in development, but it shall look like this in the future. So what you do in the type distributor, you have your electrical design type from your planning tool, which you imported earlier, and you have your bay type, which you created in the type designer. So now you have to match the actual bay, to a bay type. This matching can only be done if the bay type contains the right amount and right types of equipment, of conducting equipment, that the bay also has. So it makes no sense, for example, when the bay had 3 disconnectors, but your type only have 2, then you cannot match these bays. Yeah. So that's the first step. Match the bay and the bay type. After that is done, you can create SIEDs, specification IEDs, which are basically containers for the IED description. You add access points to these SIEDs, and then you can drag from the bay type the whole functions or single L nodes into the access points of the different SIEDs. So by this action, you distribute your functionality to different IEDs. That's why it's called type distributor, if this makes sense for everyone. So what you get in the end is you have your bay type, your electrical bay, matched with your bay type, and also you created IED descriptions which contain the functionality of this type, and you have defined which IED plays which role into the functionality. So you get a whole IED data model out of this, based on your functional description of your bay. This is the whole idea. So, but right now it's not possible because it needs to finish type distributor. So we have to do a quick workaround and create virtual IEDs via the menu entry, and then build the data model sort of manually into it, which is now a lot of work, but it works. But none of this will be necessary in the near future when the type distributor is finished. Okay. So after the type distributor, we have data models of all IEDs, and we know how many IDs are there and what's the role in the substation. So, but now these IDs have to speak to each other. So we have to get them in the same network. It's where the communication plugin comes in, where I can add subnetworks to my IDs, to my access points, and give them IP addresses, subnet masks, and probably all know how this works. It's not rocket science. So that's everything we do in the communication plugin, basically. So then we have to define which data shall be published from one ID to all the others. So for this, we have to first create a data set in the publisher plugin, where we select which data shall be present in one data package. And then we have to choose over which protocol we want to publish this data set. So shall it be assembled data, shall it be a GOOSE, or shall it be a report? This is all managed in the publisher plugin. Here you can also see how the selection of the data attributes for the data set works. It's a tree structure where you can click which part of the data model shall be contained in the data set and which shall be not. Here, for example, we create a report with the data set we made earlier. So we have to add a report control block to our IED. Then select the existing data set and link it to the report control block. So the report knows which data it shall be sent. Then we have to give the report control block a name and set its parameters. So when it shall be triggered, what shall be contained, shall it be buffered or not, and so on and so forth. It is all done in the publisher plugin. So after publishing the data somewhere in the network, another ID has to subscribe to the data. Otherwise, this action would be pointless. So in this Substation plugin, we have to select the ID and then click this chain button to let the ID know it has to subscribe something. Then we have to select the published data, the report, and then link the report that we want to subscribe to the internal IED data model where it should be contained. That's basically the communication. So after we've done all this communication stuff, the SCD is finished in theory. So now our SCD contains everything that goes on in the substation, from the physical reality to the functionality, to the communication, to the IDs. Everything is in the SCD. The SCDs are one single source of truth. There's no other file aside the SCD that contains something. So it's only the SCD, the only output. So this SCD, then I can import in my IED configuration tool and extract from the SCD the IED configurations. So the data model and the communication structure for one IED is then contained in one CID. This CID then I can load in my IED, and the IED will execute the functions and communicate with the other IEDs like specified. So there's no data re-import from the IED over the ICD to the SCD. So only the SCD says what should be done, and the only thing the IED has to do is execute. So its data stream is one direction. So after loading our IEDs, our project is basically finished. Now we have to document our project. So and since all data is already present in the SCD, we can also automatically extract every information from the project and automate the documentation, which comes in very handy. So for this, we create in the Autodoc plugin templates. These templates define which data in which order and which presentation shall be contained in my document or specific documents. You can create more than one template. I create this template hopefully only once for all of my projects, so every documentation looks the same. And then Autodoc loads this template, loads the data from the SCD, and generates with one click of a button the whole project documentation fully automatically. So, and that the documentation looks like the template, but contains the data of my one specific SCD that I'm working with actually. So yeah, that's what Autodoc do, and yeah, it's a great plugin, I have to say.
Right, then I would talk a little bit more about the location manager. Like mentioned before, we have the possibility to create locations. It's all stored in a database. And yeah, we have, for example, here 4 substations with different locations. And we have here a description. And on the right-hand side, you can see how many resources are stored within the location or assigned to the location. Let's say it like this. So it's possible to filter for this. Here right now, it's very easy to see how many substations we have. But if we talk about a big TSO who has something about 200 or 250 substations, it's very helpful to have this filter function included. After we have added a location, we can then go in the next plugin in the location viewer. There we can set for specific files, for example, this S1 webinar CoMPAS project. It's an SSD file. We can set the location. Here we said, okay, now this is the substation LF Energy. And yeah, we changed the data lastly on the 1st of December. So it was 2 days ago. And we have here the current version, which is stored on the database. Also, we have the history viewer where we are able to check the versions. So it's very helpful to store the data not local on your PC, but in a database. And in the database, changes will directly also change the version number. So we will have, if you upload it via CoMPAS, so the version will, or the CoMPAS will ask you, is it a major change, a minor change, or just a patch? And then the version number will change. If you want to see the complete history of a specific file, then you can go onto that icon or that button, and then you see, okay, there were 2 versions, for example, like here, and you can look into them and download them as well. So that was it from the, let's say, database side. What we also have as a small outlook is the validator function for the engineering wizard. So it will be an extension. And we have seen that it's very important to have not only the mandatory IEC 61850 validations, but also some rule-based validations who are specific, for example, for Transit BW or other TSOs. They're working a little bit differently, and there will be the possibility to have various rules to increase the quality of your SCD file in the end, and that you don't make mistakes in the beginning, and you have the best SCD you want to have in the end. So you can, for example, have a rule to have a specific number of minimal LNs for a BPU or a specific other ID. Is your IP address range correct of the IDs, and so on and so on. So the main idea is to mitigate the errors and increase the quality as well as the transparency. This is the current mock-up from the solution. We are developing it right now. And right now, I want to go into the live demonstration to show you a little bit more how it's working, how it's feeling. And yeah, therefore, I have to change my screen. Just a second for this. Okay, you see it's in the database. So we have here a specific CoMPAS distribution where we included all the plugins we need. Here we have our file we want to use for that, and then we open it. Yes, so we see here a lot of different plugins we can select. And what we want to show you in this webinar is the engineering wizard, how it's working in detail. So we have here a standard process, which Christian and I had somehow prepared before the webinar. We can have a quick look into the process. And first of all, it's possible to edit this process. Here below, we can see, and of course, now I have a small glitch. So we have here 3 groups: types, configuration, and documentation. We could remove any of those plugins with the minus. We can edit groups and add groups so that we are completely able to structure our process like we want it. So first of all, I have to open, this is my somehow book, so that I don't miss anything, because it's a lot we want to show you. All right, then I want to first of all delete this plugin because we will not need it for our demonstration. Then I can show you how it would work if I want to add a plugin. For example, I add this plugin here, the publisher, and now we see, oh no, the publisher must be before the substation. Then I can change the order. So we have right now the communication, publisher, substation, and communication explorer. So that's it from the creating the engineering process with the engineering wizard. And now we want to go into using the engineering wizard. So first of all, we have here on the top our different, let's say, groups. You can see them here, types. This is the selected group. The first plugin we will use is the template generator, and the next will be the type designer. Then we have here on the right-hand side the next group, the configuration group, and here the documentation group. First of all, I want to add the L-node type. So I have to write here, okay, LN0, and this is, for example, for the webinar. Then I select the class and say, okay, create this for me. I will jump already into the data modeling itself. So what I can do here is click at this eye to focus only on this specific reference data type. So there is missing a reference, like you can see with the red sign here. And we will now create our own data object type. So I now say, okay, this is our ENS behavior mode. Then the common data class has to be a ENS, and then I say next, okay. And you see it will open another window, and there I need a enum, and I know this is right now not completely done, but it will be fixed soon. I need a, let's say, behavior mode kind. There will be already one there, but I will show you how it's done completely. So we have here our behavior mode kind webinar, also from behavior mode kind. So here I can select and deselect the values I want to use for the behavior mode kind webinar. Here you can see that, and save it. I will then drag and drop it to my status value, which is how you can see here, mandatory. And I can, for example, check and uncheck the data if I want to use those values as well in my data object type. So that's also maybe very important. We have a edit mode here. So the edit mode shows me all the possible entrances per, let's say, data object, logical node type, and so on. And if I want to see, okay, what's really included, then I see, okay, this is only included in my TENS behavior mode kind. I want to then save those data, then drag and drop it. First of all, I will mark it, so I focus it, and then I want to look, okay, which one do I want to drag and drop to my behavior mode kind. I will choose this one because this one I recently created. So that's it from our side here. We see it's very simple, not to overwhelm you, but here we can see this one has one more entry than the others. That's due to the fact that we here checked the block ENA, for example. All right. So that's it from our template generator. Here you can see all the other logical node types, and there's also the possibility of default types. For example, there is the LNN0, and if I want to be very fast, then I can say, okay, set as default. Then I would say, okay, set this logical node LLN0 webinar as the new default type. Then I say, okay, let's replace this. You can see it on the right-hand side that it worked correctly. And now it would be possible to, oh, sorry for that. This was the wrong order. Now I would be able to say, okay, I want to change the LNN0. No, that's not correct. So now I will be able, I can show it here, that, for example, if I set this as default, then the default would change if I, how can I show it to you? Just a second. No, this is not working right now. Just a second. So I will now create a second LLN0. And in the second LNN0, I want to show you how it's working with the default. So we have set the behavior as default, and I want to just press here, okay, apply me the default we previously have set. So now I applied the default we previously had set, and it's quite easy. And I don't have to look into the types here. I only can say, okay, this is the standard way, this is default. Let's do it like that. Okay, that was it, first of all, from the template generator. Then in the second plugin, the type designer, we have now here on the right-hand side the logical node types. And with the logical node types we previously generated, we want now to add functions. Within those functions, we have some logical node types. We can drag and drop them to the function like this. For example, let's take an TCTR. No, this is working. And then after we have created this new function, we can create new conducting equipments, for example, a current transformer, add it here, and then we can drag and drop our function to the current transformer. So the equipment type has now the function to, for example, including the TCTR and the LNN0. After we have created the current transformer and all the functions are added to him, we can add the equipment type to the bay type. And that's how it's done, actually. It's not quite complicated. It's really easy, and yeah, it's a good workflow, I can say. All right. As we can see, we have here a small glitch because actually single diagram should not appear. But we will go then after the type designer into the type distributor. We have already mentioned it. This is under construction. Afterwards, we want to go into the communication section where we add a new subnetwork, for example, process bus or station bus. We keep it quite general to say just, okay, this is network 1. We add it like this, and then we select our BPU and BCU and save it here. So now we have included 2 IEDs, the BCU, the Bay Control Unit, and the Bay Protection Unit. And we can now edit the IP address as well as the subnetworks and VLAN settings if we wish to. So I save those data. I have to do it also with this one. And that's it actually from the communication plugin. So after we have changed this and adapted our network, we can go into the publisher plugin where we set up our data set. So we will have, oh, sorry for that, there is a small glitch. I don't know why. Sorry, I have to reload it, else it won't work here. Sorry for that. So another try. So you see it's working actually quite fast. So sorry for the inconvenience. Here. Okay. So, okay, sorry, I missed the right order. Let me just change it. Now it's working. So now we're, I don't know why it's not working right now. That's a little bit sad. Okay, but here is only just a icon. It should like look a little bit different, but maybe there's some issue with the browser. We have sometimes the issue that the cache is not resetting correctly, but that's not too bad. So actually it's working fine. So we have here our new data set. You have to select here the data set first of all, and then we can give it a name, for example, webinar name. And yeah, then we save it here and we added okay. I don't know what's happening here right now, but here we have, for example, the TVTR, the behavior, the quality attribute, status value, and the time. We will save this, and afterwards we have to say, okay, who wants to use this data set? First of all, I will select the Bay Control Unit. Then I can say, okay, I want to use this Bay Control Unit, this data set we previously created, and it includes all the data we previously created. So that's it from the publisher tool. Now we want to set the information for the client. So this was from the BCU, and now we want to, not subscribe, but get the data from the BCU. You see it here. So the report control, and we want to connect it to the LNN0 of the Bay Protection Unit. Then it's connected, and that's it. To have a quick check if it's working, we want to go into the Communication Explorer where we can click on the BCU and see, okay, here we have the logical node, TVTR, instance 1, and there we have the quality from the data attribute name, the status value, and the time. So that worked quite well. And then we are more or less finished with our configuration, and we will go into the Autotalk functionality. First of all, I want to say, okay, I want to create a new template, add an element. I want to add a text element first of all. And here I want to say, okay, this is a webinar description. And then I can, for example, add a picture. So this one here is small, medium, or large. And then I can say, okay, here you can see a NCIT measuring current. So I can do a lot more of those things. There's also the possibility to use regex, but it's more complex to show it to you in the short time here. But we can do a lot of things with this Autodoc template, Autodoc plugin. And yeah, now I can generate the document. And if we look into the document, then we have very fast, a good documentation. This is just the beginning here. And yeah, this is how it works in general. The next, I want to go a little bit into the location manager, where I can add a location by the name, let's say, Berlin 2. And the key will be Substation 4 and save it here. So here we can see there is no resource connected to that. We can do that afterwards in the history viewer. So first of all, I have to do a short database request. And then I see, okay, we have here five plugins, five files, and those files are connected. No, there's missing one. Sorry. Yeah, actually, there should be the possibility that you see in the location viewer the locations, and afterwards we have here the possibility that the SSD files and their versions are able or can be assessed. So we have here in the history viewer the SSD files with different versions. I can download them here. I have a unique ID. If it's the same file and kind, so it has the same UUID, and if it has a different one, then it changes, of course. So that's it from the demonstration. Sorry for the small glitches. Actually, we tried it 3 times before, but it was not good enough, like we can see, but that's not too bad. So yeah, what have we achieved? Right now we have established we have right now then established engineering process. It's guided and completely consistent. We have enhanced and intuitive UI concept. If we talk, for example, about the engineering wizard, but as well about the template generator, the very beautiful type designer. We have hopefully a extension of user group, because you don't have to be the super expert in that topic. And yeah, we are following completely the top-down approach. So what are the next steps? We want to improve, of course, the plugins. And like you have seen here, the browsers are sometimes a little bit complicated and do not behave each time correctly. We want to start the development of the Engineering Wizard validator, maybe AI supported, because some rules could be set up with AI. We want to continue with the type distributor, and yeah, hardening as well the engineering process. For example, maybe the virtual ID will be changed with or will be disabled there, and we will use the type distributor for that. As well, it's very important in that topic because it's a critical infrastructure that we implement a 4 eyes principle rule, more or less that it's not possible to push data into the database if there have not two different people looked over the data. A little bit like it's done in the GitHub environment where you have also the pull request topic. As well, we want to go with you into a testing phase and we want to implement your feedback. And yeah, we would be very happy if you want to share with you your thoughts and ideas. So thank you very much. Any questions? So this was Christian and me, Stefan, and I will hand over back to Dan.
Yes, and we do have a few questions. Just a reminder, anyone who has questions, please use the Q&A tool in Zoom. So we'll take it from the start. The first question was, is there any possibility to create the same web window and all the nice plugins as you show in the demo? Is there any manual of how to reach this point via installation and configuration?
There is no current manual how to reach that point, but we will soon publish as a manual and also all the plugins because they are currently under development, but we will publish them at latest, I think, in the beginning of January, because you have seen there were small glitches there, but it will be available quite soon, and you will have a good manual for that. And if you have any issues, don't hesitate to contact us because actually we hopefully can help you there.
Yeah, but you can go to the LFNG CoMPAS project, the main page, log in, and then you can open the CoMPAS demo, which already contains many plugins and functions. You can start with them. Not all plugins, like Stefan said, are available there, but soon will be.
Wonderful. The next question, are there built-in suggestions in the technical key naming and bay naming referencing IEC 81346 so that IED and merging unit names are standardized as well as the 61850 HMI?
Actually, that's a good question because we before in the morning talked about standardized naming. And yeah, we are thinking about it, getting the data already from the electrical planning tool. So actually, they will give us then the technical key naming, and hopefully this will solve the solution. So we are in contact with one vendor who is working with TransIBW. They are already able to export SSD files. Yeah, and this is also on our agenda. Let's say it like this.
Great. This one comes from Sander.
Yeah.
When can we expect the wizards in, I believe this is supposed to be demo.compass.energy?
Yes, as I mentioned, I hope it's in the beginning of January.
Perfect. Next question. Sorry, I joined late, so maybe missed this. Is it possible to host this SCL editor for offline web server use without internet connection active?
Yes, for sure. You can use the whole SCL editor without any internet connection. You only have to download it once and bring it via stick or differently onto your computers. So there is also a good manual on the wiki of OpenSCD or let's say CoMPAS. So it's possible.
Perfect. Next question. If I have prepared an SCD file using OpenSCD and then want to import it to the specific IEDs by means of an ICT tool, how would it be matched or mapped to ICD of a specific manufacturer Or how can it be ensured that it is exactly and correctly matched with what is available in the IED's ICD file?
I'm sorry, I have to read it.
Um, yeah, right now, it's not so smoothly possible like we wish it would be. So this topic we have to place at the manufacturers that they create open, yeah, minded IEDs, universal IEDs that can import the IED specification I specify, which works with some manufacturers to like 60%. What we need to work with the manufacturers and the other TSOs and DSOs on this problem.
But maybe small remark, the vendors are more open to CoMPAS than in the past. So we're getting some questions from them, and they are willing to collaborate more and more with us. So maybe this will also bring a little change into that topic.
Wonderful. Then the next question is, are there any sanity checks in place when something is not allowed being forced? Something
I
not
mean,
allowed is being forced.
the plugins are the UI of the plugins is designed so you can't do anything wrong or anything that is not allowed. Um, but like in the presentation, Stefan said, or he's the validator. The validator will then, after you set rules, what is allowed and is not allowed outside of the what the standard says is allowed and not allowed. Then the validator will check your SCD file, um, and point out what's wrong or what should not be done. Yeah.
Okay. We have time for one more question if there are any others, but that's all that we're pending. So we can give it a few seconds in case someone wants to submit one. Okay, seeing no more questions. Oh, no, thank you guys. That came in. Thank you, Kayvon. So yes, thank you to our presenters and to all of our attendees. This session was recorded, and so we will be sending out an email with a link both to the recording and to the slides, as well as some links if you want to learn more about CoMPAS. So with that, I just want to thank our presenters one more time and to everyone for attending, and we hope to see you at another LF Energy webinar soon. Take care.